5. World Wide Web. The World Wide Web, often referred to simply as the web, is an information system that allows documents and other web resources to be linked together via hyperlinks and accessed over the Internet using web browser. The web consists of web pages that are written in languages like HTML, hypertext markup language, and are accessible via URLs. These pages are linked together through hyperlinks. Berners-Lee also created the first web browser and server, establishing the foundational technologies needed for the functioning of the web. He released these technologies to the public domain, allowing for widespread adoption and development. The World Wide Web transformed the way information is accessed, shared, and communicated worldwide. It democratized information, enabling anyone with Internet access to retrieve and publish information easily. Since its inception, the web has evolved significantly. Technologies like CSS and JavaScript have enhanced the presentation and interactivity of web pages. The emergence of Web 2.0 brought about social media, user-generated content, and interactive web applications. The web has facilitated e-commerce, allowing businesses to sell products and services online. It has also revolutionized communication through email, instant messaging, video conferencing, and social networking platforms. The web continues to evolve with advancements in technologies such as AI, blockchain, and the Internet of Things, IoT, leading to new possibilities and applications. 4. Graphical User Interface. A graphical user interface is a visual way for users to interact with electronic devices or software through graphical icons, buttons, and other visual indicators rather than text-based commands. Before GUIs, computer interaction relied heavily on command-line interfaces, where users had to input text commands to perform tasks. GUIs revolutionized this by introducing visual elements like icons, windows, menus, and pointers to make interactions more intuitive. The concept of GUIs was pioneered by Xerox PARC in the 1970s. They developed the Alto, a computer with a GUI featuring windows, icons, and a pointing device called a mouse. Apple's Lisa computer in 1983 and the Macintosh in 1984 were some of the first commercially successful computers to feature GUIs. Microsoft followed suit with Windows 1.0 in 1985, which introduced a GUI for IBM-compatible PCs. GUIs made computers more accessible to a wider audience by reducing the learning curve. Users could perform tasks by clicking icons or buttons rather than memorizing complex commands. GUIs facilitated multitasking by allowing users to work with multiple windows and applications simultaneously, leading to a more efficient workflow. Over the years, GUIs have evolved significantly, becoming more visually appealing, responsive, and customizable. Touchscreens in smartphones and tablets further popularized GUIs by enabling direct manipulation through touch. GUIs are now ubiquitous, found not only in computers but also in smartphones, tablets, smart TVs, ATMs, point-of-sale systems, and various other electronic devices. 3. Microprocessors. Microprocessors are the central processing units, CPUs, of computers and other digital devices. These chips contain millions or even billions of transistors and serve as the brains of electronic devices. Microprocessors execute instructions, perform arithmetic and logic operations, and control the flow of data in a device. They fetch, decode, execute, and write back instructions, enabling the functioning of software and the overall operation of a device. Microprocessors integrate various components of a CPU into a single chip, including the arithmetic logic unit, control unit, cache memory, and more. This integration has led to significant miniaturization and efficiency improvements in computing devices. Each new generation of microprocessors tends to offer increased performance, better energy efficiency, and additional features. These improvements have enabled faster computations, enhanced multimedia experiences, and improved multitasking capabilities. Microprocessors are used in a vast array of devices beyond computers, including smartphones, tablets, automobiles, home appliances, medical devices, gaming consoles, and more. Their versatility and scalability have allowed for their integration into diverse technologies. Various companies develop microprocessors with different architectures, such as Intel, AMD, for personal computers, ARM for mobile devices, and RISC-V, an open-source instruction set architecture gaining traction in various applications. Besides general-purpose microprocessors, specialized processors like graphics processing units, GPUs, neural processing units, NPUs, and application-specific integrated circuits, ASICs, cater to specific tasks like rendering graphics, AI computations, and customized functionalities. 2. Integrated circuits. Integrated circuits, ICs, often referred to as microchips or chips, are tiny electronic circuits that contain thousands to billions of electronic components like transistors, resistors, capacitors, and diodes fabricated on a semiconductor material. ICs revolutionized electronics by integrating numerous electronic components onto a small semiconductor chip. This integration drastically reduced the size of electronic devices while increasing their performance and reliability. There are various types of ICs, such as analog ICs, used in amplifiers, voltage regulators, etc., digital ICs, like microprocessors and memory chips, mixed-signal ICs, combining analog and digital circuits, and ASICs, application-specific integrated circuits, tailored for specific functions. Integrated circuits are found in almost every electronic device we use today, from computers and smartphones to medical devices, automobiles, household appliances, and industrial machinery. 1. Transistors. Transistors act as switches or amplifiers for electronic signals. They control the flow of electrical current by using a small input signal to control a larger output signal, making them vital in digital and analog circuits. Compared to their predecessors, vacuum tubes, transistors are much smaller in size. This miniaturization enabled the creation of smaller, more portable, and more efficient electronic devices. The invention of the transistor in the late 1940s by William Shockley, John Bardeen, and Walter Brattain at Bell Labs revolutionized computing. Before transistors, computers used vacuum tubes, which were large, unreliable, and generated a lot of heat. Transistors made computers smaller, faster, and more reliable, laying the groundwork for modern computing. Over time, transistors have continually evolved. From the early bipolar junction transistors, BJTs, to metal oxide semiconductor field effect transistors, MOSFETs, and beyond, each advancement has improved efficiency, speed, and reliability in electronic devices. Transistors are everywhere, in computers, smartphones, televisions, radios, medical devices, and more. Their versatility and reliability have made them an integral part of the modern technological landscape.